Hello. So today's session is our session 2. So my course is RF system design, that means radio frequency system design. Course code is 21EC 213016, and here we are going to discuss importance of power amplifier design for RF and microwave circuit. So now we are coming to the session aim of the session, that means we are going to familiarize with the RF system power amplifier design. These are the session outcomes. So here we are thinking about the theoretical and practical aspect of circuit design, and here we are thinking about the outcome is student will know about the power amplifier behavior of RF circuit and what upper frequency and conventional circuit frequency we are using, whether it is appropriate or not. So now we are thinking about power amplifier. So this is one circuit diagram of a power amplifier. You can see here this circuit we are thinking about a power amplifier power transmitter or receiver power amplifier. You can use any one. This can be used in any one of the things. So here you can see what I did is this circuit I have taken from one book, that is reference book. So here it is the transistor. This transistor is this side is the matching input matching circuit, this side is the output matching circuit, or we can say interstage matching circuit. If it is the second stage, if third stage, fourth stage will come, third, four, like that stage will come, then we can think it is as the interstage matching circuit. If a second stage, then it is known as output matching circuit. So here we are using the blocking capacitors. You can see these two capacitors are known as your blocking capacitor. What is blocking capacitor? That means if we are giving some signal, that means here radio frequency, but every time when we are designing a circuit, we need to make it a biasing. So biasing is always the DC. So this DC plus this radio frequency, when two are added, then we can we are sending this frequency to this. So capacitor, always we know Xc is equal to 1 by 2 pi Fc. So what happen when the frequency increases, this one is decreases. So for a radio frequency it gives one path, but for the DC frequency, so DC frequency means frequency equal to 0 for a DC, so it is infinite one. Infinite means it is break, the circuit breaks. So for that no DC component will allow from this to this side. After that we are using some filters for matching network. So here also same concept, we are using some filters for matching network, and these are known as RF blocking network. So these are inductors. So for that it can also blocking the RF signal, because we are giving the DC signal here, so we are blocking the RF signal. How will block this one? So by inductance. So inductance we know XL equal to 2 pi FL. So if frequency is more means high, if frequency is high, then XL is also high, and due to that the inductance gives more opposing path to radio frequency. But if you thinking about the low frequency, that means DC, then frequency equal to 0. So 2 pi FL is equal to 0, that means XL equal to 0, that means it gives low resistance path to DC. So here we are giving the biasing, so for that we are giving the DC only required for this. So this is all about your impedance matching circuit and what we are using in a power amplifier to make it perfect for RF microwave design. Okay. So now what are the steps? So the steps already I described, but again I am telling you, the first step is the input signal is fed through a DC blocking capacitor into an input matching network to match the input impedance of the transistor operated in a common emitter configuration. So we are using this power amplifier. So the matching is needed. So why matching is needed? To ensure optimal power transfer as well as to eliminate performance degrading reflections. So, and step 2 is interstage matching networks. So, interstage matching network we are thinking about, that also we are using the matching network output impedance of the transistor to the input impedance of the second stage of the power amplifier. So, this is a matching between input and output of the transistor. The key component in the matching networks are microstrip lines. At high frequency, these distributed elements exhibit unique electric properties that differ significantly from low frequency lumped circuit elements. We need additional networks to bias the input and output ports of the transistor. Then next step 3 is the separation of high frequency signals from the DC bias conditions is achieved through two RF blocking networks called radio frequency coils. These things already I described in previous slide, but this is the write-ups. Now we can see if you are coming to dual stage, so then this side is the RF in, this side is the RF in, so that means it is RF out, it is RF out, so it is a dual stage transistor IC. So here we are using the transistors and this side is the DC biasing, all are, you can think it is the strips, it is one practical printed board I am showing here. So here the microstrip lines as copper traces of specific length and width, always all the coppers have the specific length and width. Attached to the microstrip lines are chip capacitors, resistors and inductors. So what are the chip capacitor resistors? I will describe in the next sessions. Now, if we are thinking about power amplifier, we are thinking about the requirements. What are the requirements? First one is microstrip line impedance behavior. A student must have to know. A learner must have to know microstrip line impedance behavior using Smith chart. Second one, measurement of a complicated circuit using simple input output through the two-port network. So here measurement of a complicated circuit we need to do using the two-port network. Next is we need to learn about impedance versus frequency response and matching network. Third one is functioning of active RF components. So whether it is a large signal or small signal circuit, we need to know that one. Amplification requirement related to gain, linearity, noise and stability, that also required to know when we are thinking about the RF amplifier or RF power amplifier requirement. Oscillator and mixture, that also we need to know when we are thinking about a power amplifier, because power amplifier we are going to use in all over the circuit of RF systems. Now we can think about self-assessment questions. These are the self-assessment questions. So I have given two, but in our class I have given you more number of self-assessment questions. And here these are the terminal questions. So these are the terminal questions we are going to use, and the reference are same, and here I am using this reference point and this Devendra K. Mishra, these reference points, and these are the site links to complete. So these are the thank you. This is the completion of our second session of module 1.